Next up, we have Nick on the Topics API, which is part of the Google's privacy sandbox. So this is, I think, like a very interesting study. And please.
Thank you so much. Hello, everybody. Can you hear me? Can you all hear me? OK. So yes, as he gently introduced, I'm going to talk today about the robustness of Topics API to a re-identification attack. It's a work that I coordinated with Martino Trevisan, Emilio Leonardi, and Marco Mellia. First of all, we have to understand what's actually Topics API. Well, Topics API are the solution which has been devised by Google to try and go beyond third-party cookies. We all know the problem with third-party cookies. They basically are very useful to tracking the users across their websites, the website they visit. And so Google said, OK, let's try to develop Topics API. They tried with Google. They had a little bit of a backlash from the community, so they're trying again with this Topics API. So how does it work? Topics API try to find a new balance between the usefulness and the privacy. First of all, the browser internally collects the visits that a user performs on websites, and then maps the visits to the topics they refer to. So for example, if I visit the New York Times, I will visit a news-related website. And then what the browser does always internally is to rank the topics from the most popular to me to the least popular, and just select the top 5. And these top 5 basically are a profile of the users in the past week. So then there's interaction with the advertiser. So we have this user, we have his 5 topics profile, and the user visits, I don't know, again, the New York Times. In the New York Times, there's an advertiser which asks for a topic. And the user then randomly picks one topic from his profile. It doesn't depend on the order, so in this case it's travel. And this way the advertiser can show some relevant, hopefully relevant advertise. Well, keep in mind that Google chose to give the possibility to the API in 5% of the cases to just show a random topic, okay? In this case, gardening, which does not relate at all to the user. But it is to give all the topics the possibility to appear, even the most rare ones, and also to give some plausible deniability to the user. So we observed this new framework, and we said, OK, can we still try to attack it? So is it robust to re-identification attack? First, I have to explain to you a little bit the threat model. So we have an attacker, and we have 2 colluding websites. And the colluding websites, using first-party cookies, which will remain in this solution, keep accumulating the website visited, the topics, visited by the users. And at a certain point, when they accumulated enough, they can say, hey, the website 1 can say, wait a second, I know a user which is interested in these topics. And the website 2 can say, I know a user which is interested in these topics as well. And then, if they collude, they can try to understand if the 2 users are actually the same user. Keep in mind that in the attack we developed for this PETS paper, we only took into consideration the attack in which the 2 sets of exposed topics are exactly the same. Of course, we can do much better than this, but it was the first thing, and it showed interesting results. Of course, for this attack to work, the 2 users must be unique on both websites. Because if there's, for example, a U7 with the same set of topics, we would not be able to exactly match. There are also other problems, but we would not be able to exactly match the 2 users. But if you remember, I told you about this 5% cases in which the Topics API will advertise a fake topic. And this, in theory, should let's say, that should allow the API to compromise the profile with some random topics, which should differentiate among the websites. Well, what we found out is that there's a simple denoising algorithm that's shown here that takes a threshold-based approach. And in this case, we say, OK, all the topics which I've seen only once on my website, I won't count them, because they might be fake. And this actually works. This improves the probability of a user, of an attacker, to actually attack. Then we try to simulate a little bit to say, okay, we have the threat model, we have the algorithm, we want to try and test it. To do that, of course, you need data. We started from data collection we had we collected during a European project called PIM City, and we had less than 300 users, and we collected their data for 190 days, more or less. And of course, we assumed the users to be stationary in their interests, and this is very important for these assumptions. And so we had all the row, each row represents a user, and each column represents the topic, the rate at which each topic is visited by each user. But of course, 268 users are not enough, so we had to enlarge this a little bit. So what did we do? In the first case, we tried two different approaches. The first one was like, okay, let's sample from the distribution that we have on our true users. So we sampled from the, okay, let's take, I need another user, and how many topics will this user visit, will this user be interested into? Well, we sampled this from the distribution of topics per user in the true data set. And which actually are the topic that these users is going to visit? Well, this depends on the average topic popularity in the true data set. And so this was what we called, this is how created what we called the IID personas. Another approach was to take crossover, sort of a genetic algorithm, more or less. We took a random couple of users, and we mixed them. Okay, on an average, 50-50, that's probability, creating new offsprings, and this way creating a new population which was as big as we like to try and do some experiments. And then we have to assess finally the attack. So we have our attack threat model data set. We took the table that I was showing you before, and we said, okay, if this is the average, we basically drew samples from a Poisson distribution, and to take the 5 topics which are more relevant. We did this for the next week and for the week after. And in this way, we simulated users visiting websites, the Topics API, collecting these measurements and offering them to the advertiser, and on the pipeline that I just explained to you. So, assessing the attack. First, we wanted to understand what's the probability of a user being at least too anonymous on one website. Because, of course, if the user is too anonymous, as I said before, there's a slightly more protected, although we can discuss about it. Well, we can see that at the beginning, and being the epochs, users will expose 1-2 topics. So most likely, there will be someone else with the same topic. So the probability of being too anonymous is quite high. Then this starts to decrease as users keep visiting, keep exposing different topics. They try to differentiate from each other a little bit. And this starts to, let's say, plateau around 25 epochs. And at this moment, depending on the data set you use, but we can say that less of 20% of users are too anonymized. And so 20% of users could technically be re-identified. Then we decided to go more deep into the probability of re-identification. And what you can see from this graph, which is, as I said, the attack checking whether the two websites have collected this identical same set of topics, there is, after, I don't know, 25 epochs, a probability, depending also always on the website, of around, let's say, 10% of users that have been re-identified between the two websites. Also, to keep in mind that this attack is very good at keeping the percentage of false positive very low. So it doesn't almost nearly happen that we find two users with the same set of exposed topics which are not actually the same users, at least in our data set. And of course, you can do more sophisticated attack. What we are trying to do right now is like trying to compare the denoised the denoised profile with the global profile, with the undenoised profile, and try to compare them, and the results seems very promising. The probability of re-identification increases a lot. And also Google, it just published a paper around it. They claim they found what they say the optimal attack, which I don't know. We don't really agree on that. But yes, so there's still a lot of work to do to find better attacks. So let's get to conclusions. Topics API are not designed to be a fully privacy-preserving solution. We know that. They're still better than third-party cookies, but as I was talking to the paper with someone, and he was saying, yeah, third-party cookies should really be the baseline, right? But still, it's better than third-party cookies. Of course, keep also in mind that these attacks, when I said 25 epochs, meaning 25 weeks, meaning half a year. So it might take up to months to become for these attacks to become efficient. But we are studying right now solutions that using redirections, so a website asking for a topic and then redirecting to another website that asks for another topic and so on. This could speed up probably the possibility of gathering topics, and so to shorten the amount of time needed to gain useful information about the user. There's a lot of things to do. This was really our first work on this. So more sophisticated attacks that I did. Try to non-stationary user interests, because user interests change over time, over the year most likely. And of course, if you have some privacy-preserving data, we would be really interested into that. Also, another thing is try to define Topics API privacy guarantees in a formal way. So, for example, what's the differential private? Is this differentially private? We have to go and look into it. And try also to understand why not, if this is information which is valuable to the advertiser, and we still don't have an answer to that. Thank you very much.
Thank you so much, Nikhil. So we have several questions, and one of them is asking whether you consider leveraging the correlations between the topics in your attack to improve it.
No, we did not at the moment. Of course, yes. Also, I was talking yesterday during a poster about the probability of comparing the exposed topics with a prior of topics. There are topics which are more relevant, more rare, and that is also valuable information.
Another question, was the vulnerability disclosed to Google?
Yes.
And was there a response or change?
We are in touch with them. We said, okay, we have this attack. We send them the paper. They also send a paper. They published a paper in which they say there is some sort of vulnerability. They are aware of that. As I said, it's not private by design.
Excellent. Thank you so much.
Thank you.